Okay, so for this one, we got further limits and graphs. Now the limits that we looked at previously were limits of x approaching a non-allowable value for x. In these limits, we actually want to find out what happens to the expression as x gets very, very large. What is going to take place with the expression? And again, it might not be very clear, because if we have x approaches infinity, then clearly the numerator is going to be infinite and the denominator is also going to be infinite, because we've got x approaching infinity and x approaching infinity. It may not be clear what we want for the, or what the expression will end up approaching as a value. So the process that we follow for this one is we've still got the limit of x as, the limit of the expression as x approaches infinity. And what we do is we go through the whole expression and we divide through by the highest power of x, which in this case is x squared. So we'll have 5x over x squared all over x squared over x squared plus 1 over x squared. Now if we consider this expression here in the numerator, that x will cancel with one of these, so we'll have 5 over x all over x squared over x squared, and that x squared over x squared will just be 1. They will give us just 1 here, and then we'll have 1 over x squared. Now let's look at that a little more closely. See, if I've got 5 over something that is infinitely large, then because the denominator of this is infinitely large, it means that this whole thing will approach a value of 0. So that becomes a 0. We've already looked at this bit, x squared divided by x squared, anything divided by itself is going to be 1, so that's got to be 1. And then we've got plus 1 over x squared. Well, if 1 over something that's infinitely large is 0, 1 over something that's infinitely large squared is going to be an even smaller 0, if that makes any sense. Overall, if we look at this fraction, we're now left with 0 over 1 plus 0. And the only thing that's important really is that because the numerator has a 0 in it, then that means this whole expression is equivalent to 0. So the limit of this expression as x approaches infinity is actually equal to 0. Alright, we'll come across here and let's see what happens with this second expression. Same process, we divide through by the highest power of x. The limit as x approaches infinity, well, let's put 6 on x to the power 5 over x to the power 5, all over x to the power 5 on x to the power 5, minus 2x on x to the power 5, minus 7 on x to the power of 5. Just dividing through by the highest power of x. Clearly, as we look at this, the x to the power 5 on the x to the power 5, that will become just, we'll have 6 in the numerator. In the denominator, this x to the power 5 and that one, they will cancel and that will give us 1. So we'll have a 1 here. This x will cancel with one of these x's, so we'll have x to the power 4, and that term will just remain as it is, 7 over x to the power 5. Now, as x approaches infinity, as x becomes ever bigger, well, the 6 just remains as a 6. We're left with that. In the denominator, the 1 just remains as a 1, minus 2 over something that is infinitely large to the power of 4, that this becomes a 0. And also this becomes a 0. So we're left with 2 minus 0 minus 0. So ultimately, the limit will be 6. It'll be 6 over 1. The limit of this expression, as x approaches infinity, will be 6. Let's move on to the last example. Again, here we've got an expression, and infinity's squared, infinity's cubed. what does it ultimately become? Let's go through the process. Divide by the highest power of x. So we'll have x squared on x cubed all over 4x cubed on x cubed plus 27x on x cubed minus 9 on x cubed. As we look at these the x squared will cancel with this one here, so we'll be left with 1 on x. Those two x cubes will cancel with one another, so we're just left with a 4, or technically with a 4 on 1. This x here will cancel with that, one of the x's here, so we'll be left with a 27 on x squared. And this one will just remain as 9 over x cubed, following the same pattern that we've looked at before as we analyse this. 1 over something that's infinitely large, the limit will be 0. This limit here, it's just 4 on 1, so that would be 4. 27 on something that's infinitely large and squared is also going to be 0. 9 on something that's infinitely large and cubed will also be 0. Again, the key thing here is not really what happens in the denominator, but what's happening in the numerator is that the numerator is becoming 0 or approaching 0. And because the numerator approaches 0, this whole expression, as x becomes infinitely large, the whole expression has a limit of 0. Right, there's 3 examples of how the limits as x approaches something that's infinitely large affects a particular expression and how we determine what those limits actually are.